Okay, welcome to the session 4 of module 1. Okay, now first we will see the definition of thermodynamics. What is thermodynamics? Thermodynamics is the branch of physics that deals with the relation between different forms of energy and heat. Or otherwise, we can define thermodynamics as the branch of physics that deals with heat and temperature and the relation to energy, work, radiation, and properties of matter. So now we'll study some of the important terms in thermodynamics. So now a system. What is a system? Here, a thermodynamic system is defined as a quantity of matter or a region in space upon which attention is concentrated in the analysis of a problem, or the space in which or into which our study is focused or concentrated. So if you consider this as a system, our study is related to only what is happening inside the system. Okay. Then around that, whatever is there is called surroundings, surrounding or environment. And this system and the surrounding are separated by a boundary. This is the boundary that separates the system from the surrounding. The boundary may be either fixed or moving. So in some cases the boundary is fixed, or in some cases the boundary may be moving also. So what is that moving boundary? What is fixed boundary? So those things we will study in detail in the coming slides. So a system and its surroundings together comprise a universe. Okay. Then a thermodynamic state of a system or a substance. The exact condition of a system or a substance is called a state. That means, so any substance, it is in a system, possess some properties. For example, if you consider this beaker or a cylinder, so in this there is some substance. Okay, that substance is say mass, it is having a mass of 2 kgs, and it is at temperature 20 degrees Celsius, and the total volume occupied by that mass is say 1.5 meter cube. So here this is one state of the system. At this stage, it is having a mass of 2 kg and it is at a temperature of 20 degrees Celsius, and the volume of this is 1.5 meter cube. Then next, if you see the state 2, the same substance, maybe it is a fluid which can expand. Now the mass remains same 2 kg. Then the temperature is at state 2 is 20 degrees Celsius, but the volume has increased. The volume has changed from 1.5 to 2.5 meter cube. Volume is changed. Okay. So that means here the state 1 is totally different from state 2 because one of the properties is different. Here volume is 1.5 meter cube, here volume is 2.5 meter cube. So here, even though other two properties, mass remains same, temperature remains same, so there is a change in the property, means volume there is change. So then we say that state 1 is totally different from state 2. This happens when we perform a process on the system. So here the process on this system is expansion process. That means we have allowed this substance to expand from 1.5 meter cube to 2.5 meter cube. So that means this system has undergone a process. The process may be expansion process. We allowed it to expand, thereby increasing the volume. So state is the condition of a substance with all the properties fixed. So even many other properties will come into picture, not only these three, even pressure, the pressure, maybe enthalpy or entropy. You will learn these things in later stages. So that is state. Next, state diagram. This is a diagram on Cartesian coordinates. You know what is Cartesian coordinates? That is, so two coordinate system, x axis and y axis, and perpendicular to that is z axis. So that coordinate system is called Cartesian coordinate system, which you have studied already in your mathematics and all those things. Then this is a diagram on Cartesian coordinates with any two independent properties being represented on the x and y axis. Two independent properties. So here pressure is one property, volume is another property. Okay. So then we are plotting on x-axis volume, y-axis pressure. So this diagram represents the state of a system at different instants. So for example, if you take point 1, this is state 1. State 1 where the pressure is P1, the pressure is P1, pressure is P1 and the volume is V1. Okay, so that is the condition of the state 1. If you consider the state 2 here volume is reduced to V2. The volume is reduced to V2. This is the volume V2. Then the pressure has increased from P1 to P2. The pressure is P2. That means from state 1 to state 2, we have conducted a process. We have done a process, and effect of the process is from state 1, volume V1, pressure P1, the substance has reached state 2. The same substance reached state 2. So if you consider the system here, there is some gas here inside this. Earlier, the position is this one. This is a cylinder and piston arrangement. So initially at state 1, the volume was V1 throughout this and the pressure was P1. Then when you move the piston to the left from state 1 to state 2, when we move the piston, the volume is reduced, see, to V2. Because of that, the work we have done on this, and the process is a compression process. We have compressed the gas. The result of that is volume is reduced. On the other hand, the pressure is increased from P1 to P2. So this is a change in state from 1 to 2. So this has occurred due to a process. The process is reduction in volume, increase in pressure, and the process is a compression process. Process is a compression process. State points are point 1 is a state point where volume is V1, pressure is P1. Then state point 2 is pressure P2, volume P2. Then path is a line joining successive state points on a state diagram. This is a state diagram, TV diagram. This is popularly called as TV diagram, state diagram. A path is a line joining successive state points on the state diagram during the change of the state. So it means this is the path, process path. So 1 to 2, this represents the path of the process. The path may be any path. Now in this process, it is 1 to 2, this is the path. It is a locus of series of states through which a system passes between initial and final state. This is initial state, final state, and see now we have moved 1 to 2. So in between, if you consider somewhere here volume is something, then pressure was something like this. Then if we come to the next point, this one, the volume is different and the pressure is different. And finally, at this point, final state, the volume is V2, the pressure is P2. Like this intermediate, there are many stages. But point of our consideration is we consider the process from 1 to 2, wherein volume is changed from V1 to V2 and the pressure has increased from P1 to P2. So then we say the process is done. The process here is a compression process. Okay. Then thermodynamic process, when one or more of the thermodynamic properties of a system change, we say that there is a change of state of the system. This change of state of a system is referred to as thermodynamic process. So now initially from V1, we changed the property volume to V2. Thereby we changed the property pressure from P1 to P2. So that means the entire state from 1, it has changed to state 2, where the properties are different. Pressure is different, volume is different. Then, so for doing that, we say that we have carried out a process. The process, as I told you, is a compression process. So this path indicates the process of the path of the process. Then work producing devices and work absorbing devices. We can classify the devices into two categories. One is the devices, the machines which produce the work. Then the machines which absorb the work. Because when we are talking about energy, then there are some machines which absorb energy and which produce work. So the machines which absorb work and gives energy. The steam power plant. Steam power plant, it produces the power. It absorbs the energy maybe in the coal. When you burn the coal, heat is liberated and that coal heat is used to generate steam in the boiler. Then that steam is used in the turbine to convert into work, thereby generate electricity. So it is a power producing or power developing machine. Which one? Steam power plants, nuclear power plants. These are power developing. Petrol and diesel engines. In this engine, the chemical energy is used and power or work is developed, work is done. Okay. Gas turbines. All turbines are power producing machines. Then jet propulsion engines for aircrafts, rocket engines, then fuel cell, solar cell, thermoelectric generators, all these are power producing machines. They produce or develop the power. Then some other machines which absorb the power, the cold storage system, you can say, maybe refrigerator. So it consumes the power, Then the central air conditioning and heating system, all this, domestic refrigerator, room air conditioner, ice plant, all these will consume the power, which consume the electricity, thereby perform the work. Even a compressor, all these come under maybe pump. Pump also consumes the power and increase the energy of the fluid which it pumps. So all machines or devices can be categorized basically into two categories. One is the work producing devices or power producing devices. Second one is work absorbing devices or power absorbing devices. Then now we will move on to the laws of thermodynamics. I hope all of you have studied these laws of thermodynamics in your 11th and 12th standard. You are familiar with all these things. There are the four laws of thermodynamics, which include zeroth law, first law, second law, and third law of thermodynamics. Anyhow, we just have a revision, a recapitulation. The laws of thermodynamics define the fundamental physical quantities like energy, temperature, and entropy that characterize thermodynamic system at thermal equilibrium. So, you know what is thermal equilibrium? Thermal equilibrium means the state at which the temperature remains constant. Even though there is some process going on, the stage 1 to stage 2 there is change, but the temperature remains same. Then we say that it is thermal equilibrium. Hmm? The laws represent how these quantities behave under various circumstances are the laws of thermodynamics. So there are four laws of thermodynamics. They are zeroth law, first law, second law, and third laws of thermodynamics. So entire study of thermodynamics is basically based on these four laws of thermodynamics, and we will see one by one. First, we will take up zeroth law of thermodynamics. Zeroth law. What it states is statement. So always keep in mind that statements are given by those who defined this statement. Therefore, we as a user of the statement don't have any rights to alter the statement. Definition we can change, explanation we can write in our own words, no issues. But whenever it comes to any statement, maybe here or anywhere, whenever you write a statement, statements are given by those experts who state that. Therefore, please see that the statement should be stated as it is without any modifications. Okay. Now, you cannot write in your own words. That is the point. So, when two systems have thermal equilibrium with a third system, they in turn have thermal equilibrium with each other. That is the statement. Huh? So, zeroth law is the basis for the measurement of temperature. All your temperature measuring systems. So, the right from your temperature measuring system, which we use for our general purpose. From that to high temperature measurement, all temperature measurements are based on the zeroth law of thermodynamics. So, what it states is if you consider a system A, then system B. These two are in thermal equilibrium. That means both are at same temperature. So if you bring in contact with A and B, then there will not be any heat transfer from A to B or B to A because the temperature of these two is same. Okay. So temperature, if it is different, then only heat flows from high temperature system to low temperature system. Then if A is in thermal equilibrium with B, then these two are in at same temperature. No heat transfer takes place between A and B. Similarly, if B is in thermal equilibrium with C, okay, these two are at same temperature, and if you bring in contact with these two, no transfer of heat takes place. Then A and C are also in thermal equilibrium. That is the statement. A and B are thermal equilibrium, B and C are thermal equilibrium. Then naturally A and C are also in thermal equilibrium. That is the statement, the explanation for the zeroth law. It states that two bodies which are in thermal equilibrium with a third body are in thermal equilibrium with each other. That is the statement. Then all these thermometers, whatever the thermometers which are used for measuring temperatures, use this zeroth law as the basic law for measurement of temperature. So, for example, alcohol or mercury in glass, whatever the doctors use to read the temperature, mercury or alcohol in gas. Uh, so then the property adopted for measuring the temperature is length, change in the length. Say whenever it is subjected to change in temperature, then so there will be change in the length of the tube in which the liquid is contained. That is the property adopted. Basically, it is change in volume actually. So whenever the thermometer is exposed to higher temperature, then the liquid in that, maybe mercury or alcohol, undergoes expansion. When it expands, it is placed in a glass tube. So when it expands means volume increases. So it is concealed and it can only move upwards or downwards. So linear movement. Therefore, so it changes in the length occupied inside the tube. So therefore here the property adopted is change in length inside the tube. Then electrical resistance, the resistance. Whenever there is change in the temperature, resistance of the substance also changes. Hmm? Then the temperature change decides the change in resistance. If we can measure the resistance, indirectly we can measure the temperature. That property is used. Huh? Then thermocouple, then electromotive force. So I hope you have studied what is thermocouple. Thermocouple is junction of two dissimilar metals. So when the two junctions are at different temperatures, then there will be an EMF generated. That EMF generated depends on the temperature difference between the two joints or couples. So I hope you studied all these things. If not, then you are going to study in detail in your basic electronics course. Okay. So otherwise, if you have any issues or discussion, if you want, so you can discuss these things in my regular classes. Hmm? Then constant volume gas. Then the parameter used is pressure. Constant pressure gas parameter used is volume. Then radiation pyrometer. This is used in measurement of very high temperatures. Uh, so even nowadays, so even for small low temperature measurement also, we are using this. So you might have seen nowadays for this COVID and all that, the thermal scanning what we do. That is a radiation parameter. So this is about Zeroth Law of Thermodynamics. Then we move on to the first law of thermodynamics. The first law of thermodynamics, which is also known as the law of conservation of energy. Huh? So it states that energy can neither be created nor be destroyed, but can be changed or converted from one state to another. Okay. So first law of thermodynamics examples are fans convert electrical energy into mechanical rotation or work. Hmm? The pump which convert electrical energy into mechanical work for lifting the fluids. Plants convert solar radiant energy of sunlight into chemical energy. Uh, by a process called photosynthesis. We eat plants and convert the chemical energy available in the into kinetic energy or work. Huh? So when we swim, when we walk, or when we breathe, all these things, when we do some activity, we do the work. So that work is done using the energy available in the food. So this way, energy can be converted or transformed from one form to another, maybe electrical to mechanical, mechanical to electrical, chemical to mechanical. So like that we can convert one form of energy to another form of energy, but energy cannot be destroyed. Only thing is it can be converted from one state to another state, one form to another form. So now we will consider the first law of thermodynamics for a closed system undergoing a change of state. As I told you, system is the space or area of our consideration. The closed system means when the system is surrounded by a fixed boundary and it is closed. Okay. So then for a closed system, during a cyclic process, the sum of work transferred is equal to the sum of heat transferred. Means integral of dq is equal to integral dw. Integral is here cyclic integral. So that means if we consider a closed system, so in system there are two types. One is open system, the other one is closed system. So open system is the system in which energy transfer takes place. Also mass transfer also takes place into the system and out of the system. Mass also flows in and out. Energy also flows in and out. So if you consider a pump, for example, if you consider a pump, what happens? When you switch on the pump, what happens? The rotor rotates. So the rotation is nothing but work. That energy of the rotor of the pump is transferred to the fluid or water, say example. So then energy transfer from rotor to the water takes place. Water moves up. Then water enters the pump, takes energy, moves out of the pump. When water enters the pump through a suction pipeline at the bottom, gets energy, then moves up, leaves the pump upwards. So here, if you consider pump as a system, so both energy and mass is crossing the boundary. If you consider pump as the boundary, if you consider the pump as a boundary system, then water enters into the pump, mass flow, then after getting energy, it flows out of the pump. Mass flow takes place. At the same time, energy is transferred into the pump. Then that energy is transferred to the water and leaves. Energy enters the pump, energy leaves the pump. Water enters the pump, water leaves the pump. If you consider pump as a system, here both energy and mass transfer takes place into and from the system. So such system in which both energy and mass flow takes place is called a open system. Then another system in which there is no any mass transfer, only energy transfer takes place. If you consider, for example, a cooker, if you are heating a cooker by placing it over the stove, then whatever content inside the content inside the cooker remains same. Okay. Then you are supplying the heat, you are heating that, you are supplying the heat, temperature goes on increasing, energy is transferred into the system. So if you consider cooker as a system, energy is transferred into the system. And on the other hand, mass, there is no flow of mass. Mass inside that remains same only. Okay. This type of system wherein there is only energy transfer and there is no mass transfer. Such systems are called closed system. Pump is one in which both mass and energy transfer takes place into and from the system. This cooker is one in which energy transfer into the system takes place but no mass transfer. Another example, if you take a thermos flask, you might knowing thermos flask. So now you put some hot liquid into this and keep it. Close it and shut it. Then here into this there is no energy transfer. We have closed it and kept it separately isolated. Then no mass transfer into this or out of this, no energy transfer into this or out of this. So this type of system in which there is no either energy transfer nor mass transfer. These type of systems are called isolated system. In system there are three. One is open system wherein energy and also mass flow takes place into and from the system. Then closed system in which only energy transfer into and from the system but no mass transfer either into the system or out of the system. Third case is isolated system wherein there is no transfer of either energy or mass. They are called isolated system. Now, if you consider for a closed system undergoing a change of state means from one state to other state. There is, so if you consider this cooker, it is at one state. So inside this there is a fluid. So then when you supply the heat, it undergoes change in state. Initially temperature T1, pressure T1, mass is M1. Then when you supply the heat, then there will be change in the state. Temperature increases, pressure increases. Okay, the volume also increases. So in that case, for a closed system, during a cyclic process, the sum of work transferred is equal to sum of heat transferred when it undergoes a cyclic process. Cyclic process means whenever we conduct different processes. One process, say this is pressure and this is volume. So then from 1 to 2 one process, then 2 to 3 another process, then 3 to 4 another process, and 4 to 1 another process. So here we are allowing it to expand, increase the volume, then increase the pressure, then decrease the volume, then decrease the pressure. So it is undergoing 4 processes. One is one process, second process, third process, fourth process. So then beginning state and end state are same. The state at which it has begun, 1, pressure P1, volume V1. So then 1 to 2 expansion, 2 to 3 again increase pressure, 3 to 4 compression, volume reduces. Like this it undergoes different processes. But whatever the beginning of the process, cycle and end of the cycle are same. So then that set of process is called a cyclic process. Cyclic process is one in which the beginning and end of the states are same. Then if we consider a cyclic process, if you consider a system which is undergoing different processes and the end of the beginning of the first process is same as end of the last process. Cyclic process in which beginning of the first process is equal to the or same as the end of the last process. So then we say that this processes leads to a cyclic process. Now we consider a closed system undergoing a cyclic process, then the cyclic integral of the total heat transferred is equal to total work done. That is the meaning. That means whatever the heat transferred and whatever the work done, both are same. That means whatever the heat transferred is converted into work. Whatever the work done is converted into heat or energy. So that is the meaning of this first law. It states that for a closed system during a cyclic process, sum of work transferred is equal to sum of heat transferred. So for a closed system during non-cyclic process, it is non-cyclic. The state 1 is different and state end, the beginning is different. They want to do something like this. So here there is no coming back to the beginning point. In that case, when it is non-cyclic process, the work transferred and heat transferred may not be equal, and this difference is accounted for by a change in the internal energy, or simply energy of the system. Hmm? That means whenever there is a change in the state of the system, then there will be change in the internal energy of the system, because so suppose if we heat it, its energy increases. When we cool it, energy it lost. Huh? So if the beginning and end are not same, the state 1 is different and state say 4 is different. In that case, there is a difference in the energy possessed by the substance at point 1 and at point 4. The difference is nothing but change in the energy of the system. Okay, so it is written as Q is equal to delta E plus W. So Q, heat transferred, is equal to work done plus some change in energy. Work done plus some change in energy. Change in energy may be positive or negative. Energy increases positive, energy decreases negative. Okay. So now further, the first law of thermodynamics statement: during a cycle, a system undergoes the cyclic integral of heat added is equal to the cyclic integral of work done. If it is a cyclic process, that means the state at the beginning of the process and the state at the end of the process are same, then we say that it is a cyclic process. In a cyclic process, the cyclic integral of means the total heat transferred is equal to total work done. Mathematically, first law is written like this. Mathematically, first law is written this way: cyclic integral cyclic dq is equal to cyclic integral dw. First law is applicable to closed system and to a thermodynamic cycle and not to a process. Always keep in mind. You cannot apply this first law to a simple single process. It is applicable only to a cyclic process wherein the substance or the system undergoes change of states from 1 to from 1 to 2, 2 to 3, 3 to 4, then different stages, and then come back to original. It completes a cycle. For such cyclic process, then we can apply the first law of thermodynamics. And for cyclic process, cyclic integral means that throughout this process, 1 to 2 we do some work, 2 to 3 supply some heat, again do some work, then supply some heat, something it happens. Then at the end, it reaches the initial point. In that case, cyclic integral of heat transferred is equal to cyclic integral of work done. That is the statement of first law. Then internal energy is it is the energy possessed by a body or a system due to its molecular arrangement and motion of the molecules. If you consider any system, consider some fluid in a container. So this fluid, because of its state, it is at some temperature, at some pressure, some at height, or it's moving at some velocity, then because of its states, it possesses some energy. That energy is called internal energy. So this energy is equal to the total or sum of internal kinetic energy, internal potential energy of the molecules under motion. Okay. It is a function of temperature and can be increased or decreased by adding or subtracting heat to or from the substance. So internal energy depends on the temperature. Means to this, if you add heat, temperature increases. Means internal energy increases. If you remove heat, temperature decreases. It means internal energy decreases. Even if you supply pressure, work done, then temperature increases. So if this do work for outside, temperature decreases. Therefore, internal energy is a function of temperature only. Okay. And then absolute value of internal energy cannot be measured, but can change in internal energy can be measured when a substance undergoes a change of state from 1 to 2. The meaning is, say if there is a substance inside this is a system, then we cannot measure the absolute energy possessed by this. Not possible. Only thing is, if it undergoes a change of state, say by supplying the heat, pressure increases, temperature increases, volume increases. So then, because of the change in the state, next at the second point, second stage, energy possessed, difference, energy possessed during the first state. The difference is change in the energy that can be measured when the system undergoes a process. Then we can measure the change in the internal energy of the system. But we cannot measure at one point, at one stage, say state 1, what is the internal energy, that cannot be measured. We cannot measure the absolute internal energy of any system. So internal energy, in accordance with the first law of thermodynamics, when a system undergoes a change of state as a result of the process in which only work is involved, the work is equal to the change in internal energy. See, means we are doing some work, we are not supplying any heat. If we consider a system, consider a cylinder and piston arrangement. This is a cylinder and a piston, and some fluid is there inside this, some fluid, maybe gas. Then here, when you compress it, when you move the piston from right to left, what happens? Say this is the second position. This is the first position of the piston, second position of the piston. In that case, move this, its volume reduces, pressure increases, due to that temperature increases, internal energy changes. Okay, so the change in energy is not because of supply of heat. We have not heated it, but it is due to the work done on this fluid. When we compress it, we are doing the work. We are transferring the work from the piston to the fluid or the gas. So that is to say that when a system undergoes a change in the state as a result of a process in which only work is involved, no heat transfer, the work is equal to the change in the internal energy. Okay, change in internal energy, that is equal to internal energy at the first point and second point. This difference, if you measure, it will give the change in internal energy. Okay, the law also implies that if both heat and work are involved in the change of state of system, then change in internal energy is equal to the heat supplied to the system minus work done by the system. Okay, so this is about internal energy. Internal energy, all forms of energy possessed by the system except kinetic and potential energies are collectively called internal energy, because a fluid or any substance possesses energy at any state. Then, so all forms of energy except kinetic energy and potential energy are called internal energy. So total energy content of a system, if you consider any system, the substance at some state, a fluid. Okay, so energy equal to internal energy plus kinetic energy plus potential energy. By definition, enthalpy is equal to H equal to U plus PV. Then, therefore, internal energy equal to U is equal to H minus PV. I hope you studied all these things in your pre-degree courses. You are familiar with all these things. So H, change in enthalpy. Change in enthalpy nothing but change in the energy content of this fluid is equal to its internal energy plus PV. PV is nothing but work done. So if you consider a piston and cylinder arrangement, this is some fluid. When you perform work on this, if you compress this to some volume, initially from this volume V1, you compress this to V2, you are performing some work. Then its internal energy changes due to the work. Then internal energy possessed later, H is the change enthalpy. Enthalpy, total energy of this is equal to internal energy plus work done on that, work done on this. So due to the work done, there is compression, and because of that, there is increased pressure, increased temperature. Okay, work done is nothing but PV, pressure into volume. How it comes is, if you draw plot a graph of pressure versus volume, initially it is 0.1. When you compress, the volume reduces to say V2. This is volume V1, volume V2. When you do the work 1 to 2, what happens? Volume reduces. Okay, and say the pressure remains same or pressure increases. When you do this type of compression, pressure increases actually. Okay, pressure increases. So then work done is equal to PV, pressure into volume. Total area in any PV diagram, the total area covered by this process is the work done. PV is the work done. That's how. So I don't think all this in detail study is not required as per your curriculum. So then I will stop at this. Then thank you for listening this. Thank you all.